Hi everyone, this video is on exercise 13E question 1, and in this video I'm going to do parts A and D. So this exercise is about finding the area between the curve, between any curve and the x-axis and the bounds. So if you remember in one of the first sections that I introduced integration, I said integration is essentially a tool that allows us to find the area under the curve. And now we are going to actually see how it works and how it helps us to find the area. So it's always a good idea to sketch these functions, but normally in the exam they give you the curve, so they give you a plot and you just need to understand how to integrate that. So these are the simpler examples, but we'll see more exam style questions later. So in part A, we have the function minus 3x squared plus 17x minus 10, and the bounds are 1 and 3. So first, let's sketch f of x and see what do we have. So it's a negative quadratic, and the bounds are 1 and 3, so it's going to be something like this. Yeah, so this a is equal to 1. It's basically saying that um, so obviously to be more accurate, we can first find the solutions to this equation and just find the x-intercept. So if you solve this quadratic, we'll get 2 over 3 and 5. So 2 over 3 is here and then 5 is here, and this allows us to then know the position of the bound. So one of them is 1, so 1 is here, roughly here, and then the other one is 3, which is, yeah, around here, maybe slightly in a different position, maybe here. And yes, so we want to integrate this region between 1 and 3, x-axis and the curve. So we want to integrate here and find the area of this region. So if you remember in GCSE, in questions like this, you either used to count the number of the squares or just try to divide the shape into a regular shape and then find the area of that by using the formula. But now we are properly finding the area by integrating the function. So all we need to do to find the area here, we need to solve this integral, which is the integral of f of x, which is minus 3x squared plus 17x minus 10 dx, and it's integrated between 1 and 2. So now it's just a simple integration, and it's a definite integral because we want to know the value. The value is the area. So we get minus x cubed plus 17 over 2x squared minus 10x, 3, 1. So we just now substitute each of these values, and then we can find the area. So we have minus 3 cubed plus 17 over 2 times 3 squared minus 10 times 3 minus 1 plus 17 over 2 minus 10. So this gives us 22. So 22 is the area, and we don't have the units here, so it's just 22 units squared. And that's the area. So before I solve part D, I just want to point out something about part C. So as you can see in the hint, they have given you the factorized version of f of x in part C. Now you might be asking why they have given that. It's just because in case you want to sketch the graph, you need to have that in this form, so you can sketch that. And as I said, in the exam, they will usually give you the plot, but still, it's obviously recommended to be comfortable with drawing such graphs. And now you might be asking, okay, how can we find such factorization? Because this is x to the power of 4, and it might be complicated. But normally they give you some nice functions that you can guess one of the roots. So in this case, as you can see, one of the roots, which is a repeated root, is just +1. So normally the solution is one of the roots at least is very nice. So you can guess that. And once you guess the correct root, I mean the root, then you can just use the long division to get to divide the function, and then what you get after the division, you can then use that for factorization and just factorize and write product of two functions. So I will show you this in other chapters. I think it's in chapter 7. But yeah, for now, let's focus on part D. So part D, f of x is 8 over x squared, and the bounds are -4 and -1. So again, we first, it's better to sketch that, and later on you will see the reason, because right now you might be saying, okay, but what's the point? Because if you look at part A, we could have just integrated without doing anything to do with the sketch, right? So because we have written the function, we wrote the limits, and then we just integrated. But the thing is that which you will see in in some of the other chapters, sorry, in the next few sections, sometimes there are some other things that you need to consider, and having the graph of the function is going to help us with that. But these are the easy cases that, yeah, the graphs won't help us. Anyway, so for 8 over x squared, in terms of its graph, it's reciprocal, but since it's x squared, it's the y value is positive, so that's why it's above the x-axis. And here basically one of the bounds is -1. Let's say that's roughly here, and then the other one is -4, so it's roughly here, and this is the region we want to find the area of. So we again integrate the function 8 over x squared, and the limits are -1 and -4. So yeah, -1 is the upper limit. Okay, now we rewrite the integral in the form x to the power of n, so it becomes 8x to the power of -2 dx. Now it becomes minus 8x to the power of -1, and then we have -1 and -4 here. Okay, so we just need to substitute now. -8 times, instead of x to the power of -1, I'm just going to write 1 over x basically. So 1 over -1 for the first term, minus -8 times 1 over -4. Okay, so now that we have written in this form, then we just need to solve this, and we get 6. So 6 is the area here.